Hi there, my name is Thomas Weeks, aka Tweaks, here at the Cyber Range. Today I'm going to be walking students through the OPNsense Firewall exercise that we're just about to publish. This is going to be going over our new one of our new shared networks environments that has its own OPNsense Firewall, as well as a couple of networks, a desktop network and a server network. They'll need to be responsible for securing. What we're going to go over first is talk about inter-team DNS host names. So a new feature of our environment is the ability for each student team to get their own unique DNS namespace. It's kind of subdomain in which all their systems reside. So we're going to go over that. And we're going to jump into setting up Apache MySQL on these servers down here. Basically, it's a LAMP stack. So that's Linux, Apache, MySQL, and PHP or Python. We're going to put Apache on server 1, I think MySQL or MariaDB over here on server 2, and then lock that down, expose MySQL to server 1, and lock down the firewall so the only port 80 traffic gets through to only server 1. And then we're going to set up some DMZ rules for securing this network from intruders being able to, if they compromise one of these systems, being able to pivot into our employee network, as well as protect our systems up here from malware in the employee network itself. So, and we're going to talk about what it takes to set up an internal zone. So this is protecting our internal employees from the internet. Unlike these systems down here, they're not serving services out to the internet, so we need to make sure that's enabled in the firewall. And finally, we're going to show what it looks like to do external security audit scanning. So to check your firewall rules, you can't check them from within your network. It has to be from outside. So you're going to be getting a teacher-provided, an instructor-provided SSH account outside this network environment, so you can scan inward, so you can tell if your firewall rules are working as expected. And then for the final scan, we're going to show what that looks like and what the firewall rules should sort of look like. I can't give away too much because it's a student tutorial. We don't want to give you all the answers, but I'll kind of show kind of the layout of what the rules should look like. And then some things to know, you need to know about this environment when you start working on it. So you want to watch this video kind of before you get too far into the lab, because it'll give you some useful tips and pointers. So the first thing is because when we created this environment, we had all these new host names. We need to have unique host names because you can see each other across the network. So each team gets their own unique DNS subdomain. In this case, I'm a student. I'm getting foxtrot980.example.com. So all of my systems will have that appended to their host name. So desktop.foxtrot980.example.com, firewall.foxtrot980.example.com, server 1, server 2. Looks like this. Interestingly, the edge of your network, the external WAN interface or wide area network interface of your firewall, gets the domain name itself. So this foxtrot980.example.com is this interface here. So if I were to scan, the teacher says go ahead and scan my firewall, that I would use the teacher's unique DNS namespace to scan their edge device, as well as explore their various internal IPs using those host names. So like I said, the domain is the edge. The WAN interface is your wide area network. That's kind of like the internet edge of your firewall, and then the internal names are assigned appropriately. Now, when you first start off, the teacher may have inter-team connectivity enabled or disabled. Inter-team connectivity is basically the ability to connect all of your environments together, so you can see each other, scan each other, hack each other, defend, red team, blue team, whatever you want, whatever the teacher's assigned. But until that happens, all the teams are basically disconnected. It's disabled. So if the teacher tells you, okay, go ahead and get in and scan my system or ping my web server, you may not, if you're not able to do that, they may not have turned on inter-team connectivity. So ask your instructor, hey, I can't see your server. Have you turned on inter-team connectivity? Once he does that, then you should be able to all see each other on the network. It's basically a kind of a software-defined network switch. So it allows you at that point to pass packets between your environments. This is the final state that this lab is going to have you do. So we talked about installing LAMP on servers 1 and 2, The firewall, you're obviously going to have to poke a port 80 hole through. We're not doing 443 because we're not doing certificates. This is just a basic class on firewalling and networking. So poke a hole for port 80 to server 1. Block all traffic also to the rest of Blue Network 2, so we're not exposing our database server to the internet. That would be bad. As well as creating a DMZ rules for Blue Network 2, so not allowing things in and out, and then creating the internal zone rules for Blue Network 1 to protect our employees from the internet. And then step 5, task 5, those are tasks 1 through 4. Task 5 is going to be to logging into this SSH server down here that this instructor has given us. Each student will probably get their own unique login for that. It depends on how your instructor does it. And they may give you a different machine than server 2. I've got server 2. Papa766.example.com over there on the right. This system here. So I'm going to be logging into that system as I think the user Foxtrot. So I'm going to log in over here. So that way I can then turn around and scan my system. So I can scan my server network, make sure I can get to port 80, and maybe ping ICMP, make sure my DMZ rules are working, that bad traffic can't get out from my DMZ, and that employee traffic can't get down to the DMZ, and that my employees are protected from the scans of the internet. So that's kind of what we're going to be going over. So let's go ahead and jump on my server 1 first. I'm going to go over to my environment. Let's take a look at the environment real quick. So as a student, you're going to get an environment. This is kind of verbose, but this kind of breaks down exactly what's on your network, tells you what all's there, gives you examples, and gives you your own team's DNS records. So this is my subdomain. It's Foxtrot 980, and I can copy that if I want to. Here's my desktop server 1, server 2, and firewall. I typically won't need these typically. I'm just going to do everything from command line. So it's pretty easy because after you get in here and join your environment, here's your various systems. You have an RDP login to your desktop, which I've already got open here. Right here, I'm going to go and open up a terminal. There we go. And you'll notice we changed the host name, so it gives you a fully qualified host name here, a domain name, FQDN. So practically, I mean, for internal purposes, that's what it is. So we can ping that SSH to it and as well as talk to the other students too using this. However, when you're copying this, you want to do highlight and then Control Shift C for copy, and then Control Shift V for paste, as opposed to the right click. You can do it either way, but it's faster. Anyway, just give me that tip. Then we got an SSH login to the firewall. The firewall is not managed. It's a firewall appliance. It's a web appliance. So you're going to be using a web interface from here in the actual desktop VM. So you're going to pull up Firefox and use this subdomain here. Did I open it up? Open that up while it's coming up. I've also got, I've got this SSH login to the firewall. This SSH login is just for kind of emergency use. If I lock myself out of the firewall web UI, let me show it real quick. So firewall paste. There we go. So this is the actual kind of login screen for the firewall itself. This SSH login that I just showed here, SSH firewall, is kind of the command line kind of backdoor. It's not really a backdoor because it's secure. It logs in with its own unique username. Username is student, but it's a very complex long password. And then, but to get to the firewall interface, I have to sudo su to become root. And this is how PFSense works and OPNsense works. You log in as a regular user, and then you escalate privileges to become the root user. And the root user is the one that gets put into the firewall menu. So you can reset to factory defaults, which I don't recommend. But if you mess up a firewall rule where you lock yourself out, for example, you can go to the restore backup, hit this, and I have no changes, so I have no backups. Every time you make a change to the firewall, it backs itself up. So this is the place you would go to kind of fix that if you needed to. Don't go in here and go to the shell and start installing free BSD stuff from the command line. Treat this like an appliance, not like a free BSD system. So that's my only recommendation there. I'm going to go ahead and close this because I'm not going to use this really. But I am going to need to log in through the UI. So let me go ahead and go to my environment now. Now, since all the environments are identical, except for the host names, and all the usernames used to be student. If you could, suddenly have a whole entire network of students who'd be hacking each other and logging in each other's stuff and messing each other up. So we had to give everyone unique host names. So in this case, like for example, we have this credentials. We created this new credentials tool, so I can view my environment logins and I can see my username and password for each one of my systems. I can either show it if I want to do that insecurely, or I can copy it. So I can just click copy, and just to give you an idea of what these look like, they're 3-word plus numerics at the end, so they're fairly long, secure passwords. But I don't need to see that. I can just copy to my buffer here and flip back over here and say I'm going to log in as student password. Never save. And then I get to my firewall interface. So this is the OPNsense firewall interface here, and we're going to play around with here in just a few minutes. But just to give you a bird's eye view, there's a lot of stuff going on here, a lot of graphs and eye candy and stuff you can do, looking at real-time traffic graphs and things like this. But all of our time is going to be spent down here in the firewall. Yeah, you can see some pretty eye candy. Firewall rules, and these are our interfaces. So our WAN interface, Blue Network 1 and Blue Network 2 interfaces are mainly what we're going to be messing with. So just to give you a heads up, I want to go ahead and click on WAN to get rid of this scrolling eye candy over here. Okay. So, oh man. So this looks like ICMP is, well, we'll talk about that in a minute. It's by default, these network configurations, all these firewalls are set up to allow ping through to everything. You can't do a TCP connection through to anything, but you can ping anything. So right out of the box, you can start getting ping attacks, for example, if you're not careful. If the teacher decides to turn on the network at the beginning of the class, first thing you want to do is kind of jump in there and disable ICMP from the WAN interface. So we'll talk more about that here in a minute. Let's go ahead and get back to the slides. So first thing we're going to do is install Apache on server 1 here. So let's go ahead and do that. I'm going to jump over here, and I don't need these passwords to log into my systems. I can just click join and jump directly in. So I've already joined desktop. I've got that system here. You can see that. Let's go ahead and go over to my server 1. That's where we've been tasked to install Apache. Okay, so my server 1's coming up, and I'm going to do everything as the normal student user and just use sudo. So first thing we need to do is do a sudo apt update. I can't install packages until I do an update probably, so that's just a best practice. Sudo apt update. Now if this fails, then your teacher may not have turned on this feature, inter-team connectivity. If they haven't turned that on, you're going to be disconnected from the web and everything. You can't, because all your traffic goes out the WAN and out to the internet like that. So if they've turned that off, then you may not be able to get any software updates. So I want to do that first, or you may need to tell them, hey, have you turned on inter-team connectivity? I can't get out. So try that out. Once we get that installed, we can then install Apache 2, I think is the package name. Come on. I'm doing this real time. Nothing's been prepped. This is a full live demo, so I'm sure that something's going to go wrong. Come on, Ubuntu. These are Ubuntu, I think 2022 servers. I should run screen first. Okay. Let's see. While I'm waiting for that, I can show you. Should be able to ping server 1. dot. Oh, that's my password. Be careful about that. This environment's going to get nuked anyway. So I can ping down there. Let's see if we can nmap. Port scan should be C22. Yep, port 22. So let's go down here, and I've got my updates. Now I'm going to do a sudo apt install Apache tab. I love command line completion. Apache 2. That's it. And I don't need server. Just that's it. Yeah. So do that. Of course, yes. I'm pretty sure the package by default sets it up to enable the service and turns it on. So if I go back to, since I already did a scan from up here, I'll do a comparative scan as soon as this comes up. It's still downloading headers. Man, the repos are slow today. Let me take a look at server 2 real quick. Should only be showing up port 22 also. Yep. So let me do that again. Server 1, port 22. Oh, it's up. Port 80 is up. Look at that. Cool. So if I actually pulled up another web browser, another tab, oops, wrong tab. Browser inside a browser can be confusing sometimes. So server 1 dot foxtrot 980 dot. I'm sure I got a typo in here somewhere. Oh, made it. Okay, default page. There it is. So that's my web server down here running on server 1. So now we've done this. Now we want to go over to the firewall and we want to poke a hole. Right now, ICMP can flow through here. If you look at our firewall rule, go back to my desktop system, close this out. Here's my firewall, and just as expected, yeah, we can get ICMP. Now the way the interfaces work is the data coming in the interface is where you want to affect the change. So if the data is coming in from the outside, then we want to be working on WAN 1. If we were wanting to affect the data flowing from Blue Network 2, we'd need to be working in Blue Network 2. If we want to affect the ability of employees to reach or not reach certain things, we would want to be working on Blue Network 1 interface. Right now we're dealing with external stuff coming on port 80. That would be WAN, coming from the WAN side. So right now ping is allowed everywhere. I don't want to eventually allow ping down to server 2. I only want to allow services to ping that are offering services, servers that are offering services. So first thing I'm going to do is I'm going to change this rule. And these other rules, look at them, read them. If the rule, by the way, if the rule is green, that means it's active, or if it's green or red. If it's gray, it means it's there, but it's grayed out. It means it's inactive. It's you have to click on it to enable it. These rules up here are kind of scary. This allows anything from the WAN interface to access my firewall's SSH port. That's bad. I'm going to nuke that. I don't even want that. Same thing here. TCP from outside on the WAN interface to this firewall, port 80. I don't want them accessing this control panel. If someone to accidentally turn this on like this, I don't care, when you turn it on, you have to hit apply for it to apply, but I don't want that. That's dangerous too. I'll turn that off and mark it for deleting. I don't want that. That's dangerous. And right now, these two rules will allow traffic to get into my Blue Network 1 and Blue Network 2. And we'll take care of that in a second. Let me nuke these dangerous ones first. So I'm going to delete those two rules. I don't want those accidentally getting clicked on and me getting pwned. So the from the outside, right now it can ping anything. I'm going to restrict the pinging to just my web server, because again, I'm going to allow port 80 over here, ICMP over here, but nothing here. I don't want them to even ping my database server. So we can use the existing firewall rule. Let's go ahead and do that. Let's go ahead and click edit. All right. And this is just going to open up ICMP or restrict ICMP down to my one server. Now my one server is server1.foxtrot. By the way, if you didn't know, Linux is great for copy paste. Double click, copy, middle click, paste. Very, very fast. Much faster than right click and copy and right click and paste. A lot of people are blown away by that. It's like copy, paste, boom. A lot of people don't realize that. So I'm gonna let me get the host name or the IP address of that device. I could do the same thing from here. I could do a host name dash capital I, or I could do an AP ADDR show, get my IP address like that. But regardless, I need this IP address because I'm not doing DNS entries in my firewall. I'm going to do actual IPs. Control Shift C for copying to the buffer. Now, what I'm doing again is I'm poking a hole for ICMP. ICMP. I'm going to restrict my ICMP just to server 1. So let's change this. This is ICMP v4, IPv4 ICMP. Source is anywhere in the world. Destination, change any to single host. Okay, I have my IP address. Paste that in there. We're going to be very careful when you paste not to get any spaces. You get one space and it'll puke on you. The UI will say that's not a valid IP address. Now that's a single IP address, so if you know your CIDR notation, a single IP is /32, so /24 would be like 255, 255, 255, 0, right? That's for like an 8-bit subnet. But we are doing a single IP address, so we need to lock this all the way down to /32. And ports don't matter because this is ICMP, so you can't select this on ICMP. And then we need to give it a good description. So this, I'm going to say specifically, this is a web rule, and this is allow ICMP traffic from outside to server 1. So be very explicit and the type of rule. So if it was a DMZ rule, I'd put DMZ here. If this was a some other type of rule, I'd put that here in the beginning. That's my own system, and then a more descriptive over here to the right. I'm going to go and save that, and look at the rule carefully before I apply changes. Is the ordering good? I want it at the very top. Sure, that's fine. There's no blocks or anything before it that'll stop it. Source, protocol, source, anywhere, destination, one machine. And comment looks good. Apply change. I'm going to do that. Before I do that, I'm going to, let's see, what can I do here? Well, I'll show you it's working here in a little bit, but I could preemptively jump over to my scanning system. I'll go ahead and do that to show you. The teacher in this case has given me the login foxtrot at server2 dot papa766 dot example.com. That's this server down here. This is where I'm going to be scanning from. In fact, I think I've got I've got that set up in my instructions here. So we're going to go ahead and jump on that system, and I think it's a ridiculously simple password. More simple than that. There we go. Okay, so I'm now logged into this system over here, and now I can scan over here. So I can't currently get Nmap scans, but ping, I should be able to ping right now. If I do a ping count 1 of server 1, right now it should work, right? Yep, 0% packet loss. So if I took that C1 off, you'd see it going constantly. It's like you normally would on ping. And server 2, likewise, should also be accessible via ICMP because it's star.star currently. I haven't applied it yet. But as soon as I apply this rule, locking it down just to my web host. Apply. Now I go back over here to, where'd that go? Now I try to ping server 2. I get nothing. But server 1, yay, still working. Okay, so that rule is good. Every time you want to make a rule, you want to test it immediately, so you know it's good and you can move on. So second thing I need to do is poke a hole for port 80 through the firewall to server 1. Okay, looks like I've got a rule here for allowing network from WAN to Blue Network 1. I'm eventually going to want to block that, but I'm going to leave that there for now. Blue Network 2 is where I'm operating down here, Blue Network 2. So I'm going to allow port 80. So I already did the ICMP one. Now I'm going to allow WAN TCP star to port 80 on server 1. So I'm going to take this existing rule and modify it. So I'm going to allow web traffic port 80. No, this rule down here. From the outside to Blue Network 2. I'm going to change that to just my web server. So I'm going to change this rule. So pass WAN in protocol any. I'm just going to say TCP because we already have an explicit rule for ICMP, right? So I'm just going to do explicit TCP source anywhere from anywhere destination. That's where I want to go to the single host again. Single host. Oops. Single host. Yeah, that's right. No spaces. /32. Good to go. And this is also going to be a web-based rule. I'm going to give it a descriptive name. This is a web-based. Allow all TCP. It's not all. TCP traffic from outside to server 1 colon 80 port 80. There we go. Look at that. Allow TCP traffic from outside. I'm going to be explicit and say WAN. From WAN to server 1 colon 80. I like that. That's good. I'm going to save it. Stare at it for a moment. It's not enabled yet. I want to move it up one. This is an allow rule. I like my allows grouped together. The way you move it is click on the one you want to move and then click on this arrow of where you want to move it before. I want to move it before this one, so my two web servers will be together. There we go. I'm going to enable this, turn it on. All right. I'm not going to apply it yet. I'm going to get back over my scanning system. I'm going to do a port scan. So let's say I did a ping of server 1. That works. Let me do an nmap scan with no ping, no host discovery. Right now I should get nothing because I'm not allowing it in. I haven't saved that. I haven't applied that change. So I'm getting nothing. That's what it looks like when you get nothing. It's long delays because it's timing out on each individual port right now. I want to go ahead and click apply. Apply. I go back over here. Oh, and it suddenly saw it. Yep. So that was it. Just trust me. That was see how fast it went that time. Boom, immediately. So it was timing out on some of the lower ports, I guess, or it may actually do random ports. It does a random sequencing, I think, on ports, so it's not sequential scans. So now we've opened up. Oh, but well, look, we have port 22 open. Oh, whoa, that's not good. I made a mistake. This is why we check our rules. Port 80, and I said port everything. Oh, I didn't restrict it. I'm glad I did that scan. I'm glad I love to make mistakes in front of people. This is a real world, guys. All right, so I need to lock that down to just port 22. TCP. Boink. Scroll down. There we go. I didn't do that. Hey, I don't know why here you can't use port numbers. It doesn't take like 80. But we'll take HTTP, so it's like, okay, whatever. From and to is for doing ranges. This is just one port. So if you had 443 also, you'd actually need a separate rule for that. I don't know why this interface doesn't let you do that, but whatever. Now this makes sense. Now it's actually doing what I'm saying here. Let me go ahead and save that. Apply changes. Now, what should happen? What should happen? We should see that 22 go away. Please go away. All right. There we go. Port 80. So we've locked it down. All right. So now I'm allowing from port 80. And by the way, the reason it's not just allowing everything through is at the most firewalls, I know OPNsense, PFSense based firewalls, there's if you know IP tables, there's a thing called your default policy. That's kind of like the last invisible hidden rule, which is just to dump everything, to drop all packets. So there's if you can imagine, there's a final rule down here, because packet access control lists or firewall rules flow from top to bottom. First match hits. So if I'm allowing, and then I have a deny down here, everything else will be denied. This one's not active, so you can ignore it. So I'm allowing ICMP to this machine. I'm allowing port 80 traffic to this machine. Everything else falls through to the default policy, which gets blocked. Now, I do like explicit rules. If this was my system, for example, if some sysadmin got on here and said, I need to poke a rule to allow star to everything, I like to have an explicit block rule. So I would put something in here like this. I'd say I'm going to have a default block rule down at the bottom that explicitly shows I am purposefully blocking things. Interface, IPv4 protocol, any category, description. I'm blocking everything. So description is block star : any star. Just block everything. Block everything. There we go. That's more explicit or easy to read. So block everything and save it. And this is what a block rule looks like. So you can see it's not active yet because I haven't applied it, but nothing should change because this is kind of mimicking my catch-all policy. But I'm just doing this. So for example, if I save this, if someone else comes along and says, "Hey, dude, I put up a gaming server. I want to pass everything. Free packets, free love. I want to pass destination. Yeah, dude, pass it. Yeah, my game server." So this guy comes in here and saves a game server pass rule and then applies changes. And this is legitimately, someone may be putting a test system online, for example, and accidentally does a rule like this. My security will still be intact because of that last block rule I added. I'll still be able to get to that, but it's not allowing. You don't see 22. If my block rule wasn't in there, then they'd be allowed in. So I like having an explicit block everything, and it says block right there, so it's pretty clear. Let me nuke this hippie sysadmin's rule here. Nothing against hippies. All right, so that kind of got my requirements for getting this locked down a bit. I went ahead and did this scan. You saw me do that. I tested web server access to 1. Now I'm going to go ahead and install MariaDB on server 2. I think it's MySQL. I get confused. MySQL got replaced with MariaDB, and I've seen MariaDB listed on the Ubuntu repos, but right now it seems when I do pull up, it's bringing up MySQL. So we're going to install MySQL and configure it to expose port 3306, because when you have a web server, if you're setting up, for example, a WordPress server, so this would typically be your, and this is in the cloud, but a lot of people, that want to host it themselves will need to set up a dedicated web server and a dedicated database server, and then connect the two over 3306 for the MySQL access. So to do that, we're going to have to jump on server 2. So let's go here and jump over to log into server 2. Oops, is that server 2? About to find out. Yep, clicked on server 2. Okay, good. So right now, if I do a netstat, I don't have netstat. Do SS, ANTP, I can see what ports are bound. Looks like I'm currently exposing SSH to the world. Okay, and these are the 100.nets. These are the service nets. This is where I'm currently logged in through. I'm 22 coming from the 100.net. This is the cyber range. So never block stuff coming from 100.net because that's where we connect to you guys from, connect to your VMs from. Anyway, so this shows that nothing's kind of up my sleeve. I'm only binding on port 22. Let me go ahead and do a sudo apt update. Same kind of thing here. I don't want to wait a long time. So we're going to, basically in a nutshell, we're going to, let me get back to my slides. So we're going to install MariaDB database here. Now by default, or MySQL rather, I'll just say MySQL. We're going to install MySQL. By default, for safety reasons, security reasons, MySQL and MariaDB only bind to localhost 127.0.0.1. So only local services can see its database. This is because a lot of people didn't know what they were doing, installed MySQL in the old days, and poof, instantly exposed their entire database to the internet, didn't realize it. So kind of default out of the box now is more secure. So it's only exposing to localhost. It's not, you can't see it from the internet. We need to expose it to its public facing IP so we can get to it from the web server if this ever gets done with its update. And once we do that, we're going to scan it from server 1. We'll scan server 2 from server 1. In fact, let's go ahead and do that while we're waiting. Let me clear server 1. So say ping server 2. Looks good. And map-pn should get 22. Yep, port 22. So we're good to go. In fact, I was just on there and I looked and saw that 22 was the only thing being exposed, and there it is. It's the only thing there. If you ever see something that's different, you may have IP tables config you may need to contend with on the system. That would be a good thing to do, but it's kind of outside the scope of what we're doing here today. So I might install MySQL here, for example, and then I can't really block these two systems from each other from the firewall, okay, because the traffic's going inside the LAN. But I could run IP tables here and block anything else on this network except the web server. So that would be probably a good configuration. But as soon as you start getting into multi-layer firewalls, troubleshooting becomes a nightmare. So I like to stick it all in one place and just put a DMZ around this and be done with it. All right, so we did an apt update. Gonna do an apt. I want to see what happens. Search MySQL. There's a bunch of MySQL junk. Ugh, I hate that output. So we're gonna do aptitude. I like the output better, and it's more script friendly too. There we go. So, yep, MySQL server. There it is. I don't see Mariah. Yeah, maybe I need to search for Mariah. Oh, yeah, there's Mariah. Okay, we're just going to go ahead and do MySQL. I'm going to do a sudo apt install, what was it? MySQL server, I think. Tab. Yep, that's it. Yes. Let's get that installed, and then we need to configure it for exposing itself on 3306. I'm sorry, exposing it on whatever IP address is on the Ethernet 0. We could probably just bind it to 0.0.0.0 is instead of using the explicit IP address. So when you look at a system, look at server 1 here for a second. Oh, darn it. So do a net. There's no netstat. So even though its public IP address, excuse me, even though its public IP address is 192.168.35.246, typically you'll bind things to either 127.0.1 or localhost or 0000, which is all IPs, including this one. So if you wanted to expose it to this one and not this one, then you'd want to explicitly use this IP address. In fact, I may just do that. I'm going to go and do that. Copy that. So, oh wait, this is the wrong. This is server 1. Let me go back to server 2. So it looks like server 2 did install. Let me do a sudo ss antp. Yeah, okay, 3306. MySQL is now running on 127.0.1. So that's the IP. We want to switch this. We want to change this. And I can't remember. It's been so long. Let's just become root for a second. It's been so long since I've poked around MySQL. There's my debian.cnf conf.d. There's a bunch of CNF config files in there. I know it's my.c, typically my.cnf, but if I'm not sure, I can just do a grep 127 dot o recursively on etc MySQL. Okay, there it is. Bind address. I don't know what this is, but this is the file I want to edit. Yay, that makes it so much easier. Go edit that file, and there's my 127.0.0.1. This is what I want to change. I always like to comment out when I do something like this, so I don't lose the original. And I could put 0.0.0.0 here, or I could do a, I love Vim, I can execute host name dash capital I, this IP address. Whoop. Append, paste, boom, done. Never even had to leave my editor. You guys really need to learn Vim if you don't know it. I think that's it. Now, since I'm root, I should be able to save that and do a systemctl restart MySQL service. Enter. And now if I do my netstat ssantp, now I'm not bound to 127 anymore. Now I'm bound to my public IP address. And I'm also not allowing 100net to see it. Only my only this interface can see it. I think that's what is that? I don't have if config IP addr. Oh yeah, we're not using ETH0. We're using the ENS naming structure. So only this interface can see it. This interface cannot see MySQL. So that's good to know. I mean, the difference between locking down to a specific IP interface versus locking down to 0000. That's really the functional difference. So we've locked that down. So now we should be able to go to server 1. Our web server should be able to see MySQL. Oh, there it is. 22 and 3306. Okay, we're good to go. So now we've configured that. We've already locked it down so that the world can't see it. Let me make sure the world can't see it. Go back over my scanning system here and say, hey world, scan my server 1. Should not see 3306. If it does, I'm not doing my job. Yay, still secure. So the world cannot see my data. Oh wait, not server 1, server 2. I'm not doing my job after all. Hold on a second. I shouldn't see anything because we're blocking. I don't know why I'm whispering. So that should be good. That's timing out. So it tells you 8% done. Yeah, I'm not waiting. Okay, you're good to go. So that is now secured. So we have locked down. We've installed that. We made sure this can access that, and we've started to, yeah, we blocked the rest of BlueNet 2. So I've already done these tests. This was the test that I was alluding to earlier. Um, Test server 1 to server 2, 3306, we can do it. Test WAN to server 1, 80 and ICMP. Yeah, we did that. And test scan and ping. I didn't ping, but yeah, I did ping earlier. So scan and ping between WAN and server 2 fails, which is exactly what we got. So that's kind of in a nutshell what this lab kind of has you do. There's some other things, like for example, I think in the lab we have you set up a maintenance. Um, we have you lock it down so that if you're really going to do a true DMZ, you have to not only block your employees from getting in, but you need to block your systems from getting out. This is called egress restrictions. You want egress restrictions because, for example, say you haven't patched your Apache web server. That's funny. Um, and it's vulnerable and it gets hacked. Someone on the web on the net pwns your server 1, your web server, and now they can pivot to anywhere in your company. Um, so that's part of what a DMZ does, is protects the rest of your company from that. But also, what a lot of people don't realize, you need to block off all outbound traffic from these servers out, because one thing that these servers are going to do as soon as they're compromised by like a Trojan worm or botnet, as soon as they're compromised, they're going to call home to their command and control system, in China or Korea or Russia, which is where a lot of those attacks come from, and they're going to call home and join the zombie net, and then they're going to be able to DDoS from your network out. I had NASA call me once saying, "Hey, you're DOSing us," and I'm like, "Oh shoot, this is someone else's system that they asked me to help them with because NASA was getting onto them for allowing hackers to hack their network." So this that keeps these systems from being able to DOS attack other systems on the net. So basically, you would have a block rule here. You might call it one of your DMZ rules, for example, that would block um, anything coming from Blue Network 2 from Blue Network 2, any source, any port to anywhere, block it. Right now there are no blocks here. This is just the default block after this default allow. Right now, this is what allows us to, for example, patch our systems. If I were to turn this off, this allow anything from Blue Network 2 out, if I turn that off and just use the default block that's down there, apply that change, then watch what happens to server 1 and server 2. I can no longer do an apt update because it hangs. Okay, that's because the rule that was previously allowing all traffic from Blue Network 2 to anywhere else was enabled. Now it's disabled, so it's falling through. Traffic to this firewall is okay, and ICMP to anywhere is fine, but I can't get HTTP, TCP/IP connections out. So this is going to all fail until I turn this back on. So this is the kind of blocking you want. You want this kind of blocking in place because if a bad actor takes over one of your web servers, you don't want them calling home their command and control. So all that to say is, I'm going to take a rule like this, and I'm going to give it a label like maintenance. So once a month or once a week or whenever I patch my systems, I'm going to have the system automatically turn this rule on, and have my systems automatically call out and do apt updates and do security patching at that point, and during a small window. And you want to do that in a way where they can get out, for example, but they can't get up to your employee network. So that's the kind of thing we're going to be doing in the rest of this lab that I'm not showing because I don't want to give away all the answers, because teachers want you to learn, not just copy paste. And by the way, all the host names are unique, so if you copy paste someone else's screenshots, they're not going to match yours. And so if you want to cheat, then yeah, you can get into bitmap editing and stuff, but you got a lot of editing to do. So don't cheat, learn. So I've just turned that back on, and then apt update will start working after that. See that? Now it's downloading. So we would want a maintenance rule here to allow this system to patch itself on a regular schedule. So that might be part of our Blue Network 2 edition. So let me go ahead and go through my slides real quick, and we're going to talk about the rest of that. So to set up an internal zone, I'm going to go ahead and turn this off. Like this. And then go up here to Blue Network 1 and say anything Blue Network 1 going out is fine. I would need to make a rule here for this internal zone to block incoming traffic from WAN, which I think I've got in place. Let me go back here to WAN and look real quick. So this rule says I want to block WAN star to all of Blue Network 1. Okay, well, there's my Blue Network 1. So really I want this to be a block, WAN to Blue Network 1. Yeah, I would probably edit this rule and make it into a block rule. Edit this rule, turn it into a block rule, and make this say, this is my INET rule for blocking everything to Blue Network 1, and that would effectively give me my internal zone. And then I've, of course, get on SSH and test that. And this is what you guys are going to be tasked with in your classes. That's why I'm not getting too detailed, because this is they're going to expect you to they're either going to assign you an SSH server over here to do it yourself and ask you for screenshots, or they're going to say configure your stuff and let me know when you're done, and the instructor is going to scan you. So however the instructor wants to run the class. So after that, you've got the internal zone done, you've got the DMZ mostly done, and you'll start running scans and get screenshots of that and send those to the instructor however he wants to do the class. Some instructors prefer to scan you in real time. Some instructors will want you to send screenshots and submit your work like that in a Google Drive or a LMS system. That's about it. The one thing to note, if you can't reach if they want you to scan your systems and you can't reach the system they've given you, they may have actually turned off the environment. You may need to ask them, hey, have you turned off the environment, or is the inter-team connectivity turned off? I can't reach your system. Can you please help me? So just be aware, especially if you do it like late at night, and if he says, my system's going to be on for the next 8 hours, you can scan yourself anytime in that window, then get on there and do it. Otherwise, if you log in at 3 a.m. and his system's he's already turned his system off, gone to bed, turned off for the night, you may not be able to do that. We have a feature coming up where the teachers can leave that on as long as someone's logged in over here. They'll get that ability to get into that kind of class utility system. I think they're calling it a PEG system. So those systems will be online as long as someone's logged in. But you basically get in, do your scans, and send your screenshots over. So this is the final tests that you'll be tasked with in the lab. So just to step through this, from Blue Network 1, scan and ping external stuff like the teacher's firewall or their server 2 or whatever they've allowed you to scan, whatever target they've given you. Blue Network 1, ping and scan my server 1. So scan from here down here. It should bounce off if your DMZ is set up correctly. It should be denied. Then get on server 1 and scan and ping my server 2. I should be able to scan and ping my server 2 from server 1. That's good to go. Then for Blue Network 2, scan and ping my desktop system. I should not be able to reach my desktop system as per here. And Blue Network 2, scan and ping something external. So try to reach out to either your instructor's firewall system or the SSH server if they've set you up with that. And DMZ should prevent that egress traffic like we were discussing from making it out. Oops, messed up my slides. So that last one is what keeps botnets from calling home and or data exfiltration. So they've hacked your database server, and for example, we have problems with that in universities. Is internationals getting on systems and trying to exfiltrate research data. This would stop that kind of thing because they cannot initiate a rule. They cannot initiate a data transfer from the DMZ out to the internet. So just FYI, in other forms of exfiltration, some hackers will use, some rootkits and stuff will use DNS and NTP, Network Time Protocol services to exfiltrate data, trickle the data over DNS queries out here to a listening DNS server, or trickle data over NTP servers. I've seen both used in the wild. It's crazy, but you got to be aware of that. Those are typically protocols that are just allowed to flow anywhere. So that's something that happens in the real world. By the way, if you configure a DMZ, and how do these systems get DNS? How do these systems get network time services? If you're designing, architecting a network, you need to think about those kind of things. Most people would probably use the gateway server, which in this case would be the firewall, to use to service DNS queries and NTP queries. But that's why there's rules for that in the firewall settings. You'll see things like Blue Network 2. I actually had a rule. There it is, this firewall. So this is the rule that allows Blue Network 2, these servers in the DMZ, to get to the firewall. In fact, I might rename that as another DMZ rule to allow these servers to get network time and DNS data because they're blocked from everything else. So that's good stuff. So this is kind of what instructors will probably have you send screenshots, final screenshots of each one of your network interface rules to them, so they can critique them, as well as run scans on you to see what you got going on. So that's about it. If there's any questions, ask your instructors. If there's any infrastructure problems, ask your instructor and they'll submit a ticket to us. We can take a look at it for you. Well, there's some very important concepts you need to know. So the things to know before you start kind of jumping in. So you should have, as students, you should have a basic understanding, at least a basic understanding of TCP/IP, ICMP, subnets, and CIDR notation. These are, you can't really configure firewall rules if you're just randomly clicking on stuff, right? So those are some basics. This is an intermediate to more advanced type of stuff you'd see at the community college and university level. Some advanced high school students maybe, but not your normal high school student. Host names. So be aware that each host has its own unique DNS. Each team has its own unique DNS name and host name for each VM. We went over that. Team environments can't see each other until the instructor clicks on this inter-team connectivity thing. So if you can't see, it's like, okay, scan each other, and you're like, I can't see anything. You may not have clicked that. So have your teacher, if your instructor, click that. For multi-student teams, only one person can access the Kali VM RDP at a time. So this interface here. So for example, if another team member, let me go back to my network map here. So this system here, because this system is used to administer the DNS, only one person should be doing that. As a result, only one person can really log into the desktop at a time. So if someone else jumps on this system, watch what happens. If I go over here and say, join my RDP desktop again. Okay, it pulls up, open a new tab, and I join and pick up exactly where the previous user left off, but the previous user is booted off. See that? This tab over here? That's the old user. This is the new user. So if you're on a multi-person team, come to an agreement about who's going to be the RDP person to log in here. Now, if you got a red team, blue team, if you've been given a red team, blue team assignment, there's going to be attackers, and they want to use Kali, man. They can still use Kali from the command line. They'll just probably log into server 1, server 2, and then SSH up to get to Kali. You can do it that way. And you can have as many people log into these servers via SSH as you want. That's not a big deal. So everyone could log into server 2. Maybe you install Kali tools there, or you can SSH up to your Kali system and go over. This is not for this lab. This is if they use this environment for other labs. So it's really outside the scope of this video. But just FYI, only have one person that logs into the RDP session. Otherwise, you're going to experience stuff like this, disconnects. And then there's the new person. So that's something to be aware of. For LAN and through firewall port scans, it should be done from external scans. So we talked about that when you're doing scans. Um, you can't really scan your internal stuff, your external firewall rules from inside. You got to be outside. So that's all that's saying. All VM web traffic is bound for the internet, or that's bound for the internet, goes through the firewall. So if you turn off egress traffic for Blue Network 1, for example, if you turn off all egress traffic, then they won't be able to surf. Um, so that's something to be aware of. Um, should be kind of obvious. However, all return traffic, because back here we said, okay, we're blocking, no traffic, no packets are allowed in here. Well, for desktop users that are surfing, going to Google, Google's coming back. It's getting in. That's because it's called established related traffic. So it's established because it's a client TCP connection that's formed, and that TCP connection is tracked by the firewall as the packets come back in. It says, oh, this packet is established and related to this client's session, so it lets it through. Very important concept. Established related traffic is very important to understand, guys. So if you don't know what that is, look into it more, because it's why you can block the world except for established related traffic. Okay, very important concept there. So don't sell yourself short by not digging into that. So all return traffic through web surfing or through app updates, for example, are established and related. Okay, so established related traffic is allowed through by default, unless you explicitly block it. The firewall web UI can only be accessed from the Kali VM, so I guess you could technically use a command line browser from down here to the firewall, but that would be kind of painful and awkward. So I wouldn't recommend it. Just stick with the web UI. I wouldn't mess with anything else. When logging into the firewall UI, use the firewall SSH credentials when we get in. So even though that's just to say, to get into this UI, I got to it from my environment login variables, even though I'm not SSHing in, it's the same credentials. So it's that student user and this password, and I'll show it here because it doesn't matter. So this is the password that goes with this student to get into this firewall UI from the desktop system. So get that. I log in here, get my SSH credentials for my firewall, and then point my web browser over here and log in as student and those SSH credentials. So it's the same credentials is the point. That's all I'm saying there. The default config allows ICMP through to everything, so we talked about that. So when you first fire up a blank stock system, ICMP is allowed everywhere, but blocks incoming TCP connections. So they can't connect, they can't port scan, but they can ICMP. And you can do attacks. You can do DOS attacks over ICMP. You can ping flood with big packet sizes, and there's some bad stuff you can do. So there's a fragmented packets, all kinds of stuff you can attempt. I don't think fragmented packets are allowed through, but you should eventually lock that down so it's secure. You definitely don't want people on the outside ping scanning your internal network, for example. And all rules are sorted by interface. We kind of been through that. That's what all these things are: WAN, Blue Network 2, Blue Network 1. All rules, unless manually changed, are first matched top to bottom. So that's an important concept. That's if you've never done ACL, access control list, or IP tables or firewall rules before. That's kind of a natural way they operate, top to bottom, first match. They're Boolean matches, so if that matters to you. All default interface rules, policies, or catch-all rules are set to block. That's what we were talking about when you're looking at the firewall interface. The default rule down here, if it doesn't match any of these, it is set to block. So that's how the system will behave. I just happen to like putting explicit blocks in, so I have a visual indicator, and I'll know if someone added something they shouldn't have underneath that rule. But anyway, that's just me. If locked out of the firewall, use the firewall SSH login. Let me go ahead and show that real quick. So I'm going to lock myself out of the firewall. I'm going to say I'm on Blue Network 1. This desktop is. And I'm going to turn off this Turn off, allow traffic to everywhere. So I can't get out. And I can no longer access the firewall. Okay. Network 1 can no longer access this firewall and is being blocked. Let me do a reload. Uh-oh, I locked myself out. So this is a real world situation here. It's like, what are you going to do? It's in the cloud. I can't go reboot it. I can't. So your backup plan is to jump over to your login and say, okay, I'm going to go back to my SSH into my firewall. I showed you a little bit of this earlier. Sudo restore from backup. Every change makes a backup. So that's nice. I know I can go back 2 changes. I'll go back to the third one just to make sure. And yes, do that. Invoking beep beep script. I think it actually reboots. Yeah, it actually rebooted my firewall. So I'll wait. It's FreeBSD. It should come up pretty quick. Go back out here. Where did my desktop go? Here it is. Okay, so I'm going to hit this a couple more times. Still down. This is normal, by the way. You need to know how to do this in case you lock yourself out. Because if you lock yourself out, the only way to get control of the environment again, if you've really hosed it bad, is to have your entire, here you go, it's back up, is to have the entire environment wiped, and then you lose all your changes and all your firewall rules. So there you go. I need to log back in, but you get the idea. All right, so just be aware that SSH login is kind of your backdoor and for doing restores and backups. And then never delete or disable firewall rules labeled do not remove or automatically generated. I'm not logged in right now, so I'm not going to mess with it, but you'll occasionally see rules that are say do not remove or automatically generated. Do not remove rules are rules that the cyber range has put in place to make sure the system works with the cyber range and that you don't lock yourself out. So don't touch those. And if you ever have to reinstall an environment, you will lose all your changes, your firewall rules, your IPs will change, but your host names do stay the same. So that's nice to know. If you do have to nuke it and start over, the teacher's not going to lose track of who you are, what your host name is. Other people that are scanning you, their stuff will all still be good, but your IP addresses will change. So the underlying VMs get swapped out and the host names get applied to them. So I think that's about it. This is a common thing you need to know about before using this environment. So if you all have any questions, submit tickets. Always ask your instructor first, and then if they need to escalate to us, your instructors will escalate it to us. All right, that's it. You guys take care. Have a good one.